Okay, welcome to Stats Lecture 1. You should have your notes for Stats Lecture 1 in front of you. Like I said, I think it's best to have it as a hard copy so you can just follow along with me and write in the blank spaces. Because remember, in the end, you're going to have to upload that as a PDF as your homework that I will be grading. So you want to fill in your notes accurately. So we have at the very beginning there our definition of statistics. And so what are we going to say we mean by statistics? We mean simply the science of extracting useful information from a set of data. And is that coming through all right? Looks decent, I guess. All right, what do we mean by data? Well, data come in four types. The first type is categorical. And this is often, not always, but it can be non-numerical data. And really, what we just mean here is a data set is full of categorical data if the data values have no meaning as quantities. And let's see, do I have enough room? No, I guess I better go up here. So, for example, maybe we survey a bunch of people and we keep track of their favorite ice cream flavor, all right? That's something where we just categorize people. These people like chocolate best. These people like strawberry best, right? Another example might be survey people and we get their zip code. All right? The zip code's a number, right? But really it has no meaning as a quantity. You don't look at one person's zip code and say, hey, my zip code's bigger than yours. That just has no meaning, right? It really just is a way of categorizing people who live in a specific area. All right, that's not the most interesting kind of data. The next kind of data, next type of data is ordinal. This is generally numerical data. And here, the data have a specific order from smallest to biggest. So for example, let's see, I want to say maybe a good example of this would be the pain scale that you may have had someone ask you about if you'd ever had an injury or you were sick. Someone asked you, what's your pain scale on an order from 0 to 10? Really, those numbers, they do have meaning as quantity to a certain extent in basically just the sense that if I tell you my pain is a 7, that's more pain than if I tell you it's a 4, right? So there is some sense of quantity there, but not much more than that. And you will see the other ways that quantity becomes more useful, or a way to think about it is more useful if we look at these last two, which are going to be the more important ones that we have for our study. Interval data. Here, the data have an order and differences between data values matter. So, for example, temperature, and say the Fahrenheit scale. Certainly, 50 degrees is warmer than 30 degrees. So I have ordinal up here, right? I have a sense of an ordering to how big the temperatures are. And also, I can say to you 50 degrees is 20 degrees warmer than 30 degrees, and that has meaning. It doesn't have a lot of meaning up here if I tell you, well, my pain is 7 and yours is 4, so mine is 3 greater than yours. That just doesn't really have much meaning, unlike down here where we understand the idea of a 20-degree difference in temperature makes sense. So there's a little more information here if we're talking about interval data. And lastly, let's see, not going to go off the screen. Good. All right, lastly, we have what's called ratio data. And here, the data have an order. When I say the differences matter, I mean the differences are meaningful, really is a better way to say that. The differences are meaningful. So down here, the differences are meaningful. And I think I can get it in, yeah. And ratios between the data values are meaningful. All right. So for example, we take a group of people and we measure their weight, each person's weight. So set of weights are a type of ratio measurement because certainly they are ordinal. Someone who weighs 200 pounds weighs more than someone who's 100 pounds. Certainly they're interval because if someone weighs 200 pounds, they weigh 100 pounds more than someone who weighs 100 pounds. So taking the difference has some actual meaning. But also, if I take the ratio, someone who weighs 200 pounds weighs twice as much as someone who weighs 100 pounds. So that has meaning. Up here, if I say I have 60 degrees, if it's 60 degrees, and last week it was 30 degrees, it's not really correct to say that, well, it's twice as warm today. That really actually has no meaning because of the way the temperature is defined in the Fahrenheit scale. It isn't correct to say it's twice as hot or twice as warm. So it isn't really a ratio measurement. But down here, weights or maybe heights would be another example. One snake could be 3 times as long as another snake, right? So it makes sense as a ratio measurement. Okay, well, let me give you 3 examples of data and have you pause and try to come up with which of these 4 different types each one is. So let's say number 1 will be, what do I have here? How about the number of children in a family? Okay, I'm going to leave a little space here so I can write the answer. Number 2, let's say a restaurant review. So like 0 to 4 stars. So there's a quantity there. And number 3, see a little room. How about someone's social security number? Okay, now what you want to do and what I hope you do throughout these series of lectures is when I give you something like this, you pause, you look at what you've done so far, you look at your notes, and you try to figure out the answer in each case. And when you think you have it, you write it down, and then start me back up, and we'll see if you're right. So please pause. And off I go. Number of children in a family. Well, certainly it's at least ordinal, right? If I have 5 children in my family and you have 2 children in your family, that's a bigger number. 5 is a bigger number than 2 children. Likewise, it's interval. If I have 5 and you have 2, I can say I have 3 more than you. The difference actually makes sense. But also ratio. If I have 5 and you have 2, I have, 2.5 times as much as you. So if it satisfies all of them, we'd say that this is a ratio form of data, a ratio type of data. What about the restaurant review? Okay, well, it's certainly ordinal. If I rate a restaurant as 4 stars, that's better than 2 stars. But really, is there an intelligent meaning to taking the difference? If I have a 4-star restaurant, is it really 2 stars better than a 2-star restaurant? That kind of doesn't seem to make sense. And likewise, it certainly doesn't make sense to say a 4-star restaurant is twice as good as a 2-star restaurant, right? So it's not ratio, it's not interval, it looks like it's just ordinal. Lastly, we have Social Security number. All right, well, that's a number. It's a numerical form of data, but really, it's not even ordinal, right? It doesn't make much sense to say my Social Security number is bigger than your Social Security number, right? There's no meaning to the size of the number, so it really is just categorical, isn't it? It's just that you have this Social Security number, you have that Social Security number, I have whatever my Social Security number is, so it's just categorical. It's a way of identifying, putting people in categories. Each person is in one category, right? Whatever their Social Security number is. But that's it. All right, let's stop here. And it won't let me stop.